Good morning one and all. Now in previous lecture we have seen requirements of 5G in detail, and after that we have seen different factors that are responsible for growth in IMT traffic, and later that we have seen different requirements or the different drivers for traffic increase beyond 2020. All this we have seen in previous lecture. In addition to that, we have seen energy aspects. Now what we have concluded from that energy aspect is that because energy consumption may become limiting factor, in order to avoid that there should be improvements in energy efficiency, right? This was the statement that we have concluded in the previous lecture. We have seen requirements of 5G, and after that we have seen factors that are responsible for IMT traffic, and after that we have seen factors that are responsible for IMT traffic, that is factors that are responsible for growth in traffic beyond 2020. Nothing but different drivers or the different requirements for increase in traffic beyond 2020. After 2020, what are the different drivers that are responsible for the growth in traffic, that also we have seen in previous lecture. And later we have seen the energy aspects. Now because as energy may become limiting factor, in order to avoid that we have to improve the energy efficiency, right? Now all this we have seen in previous lecture. Now coming to this lecture, in this lecture we will see a complete details of estimation of different parameters. Now that parameters includes number of mobile subscription and number of M2N subscriptions, nothing but machine to machine subscription, and growth in traffic including M2N subscription and without M2N subscription. All these parameters are estimated from the year 2020 to 2030. That means those values are just an expected values, but the actual values will differ with the expected values. Now in this lecture completely we will see the estimations of different parameters such as number of mobile subscriptions, number of M2N subscriptions, and number of nothing but growth in IMT traffic, growth in traffic including M2N subscriptions and without M2N subscription from the years 2020 to 2020. That means we are estimated values from the year 2020 to 2030 on different parameters. All these we will see in this lecture. Now all these are the estimation that are considered from the ITUR recommendation M.2370. This is a particular recommendation where you will observe a complete estimations on different parameters from the year 2020 to 2030. Now in this lecture we will see complete about the estimation values, but the actual values will differ from the estimated value. Now in this lecture we will see the estimation of number of mobile subscriptions from the year 2020 to 2030, and we will see the number of M2N subscriptions, nothing but machine to machine subscriptions from the year 2020 to 2030, and also we will see the growth in traffic from the year 2020 to 2030 including M2M subscriptions and without M2M subscriptions. All this we will see in this lecture. Now coming to first slide. Now the first slide includes the estimation of global mobile subscription, right? Now the estimation, we are estimating the number of mobile subscriptions around the worldwide. Globally we are estimating the number of mobile subscription, and this figure is taken from the ITUR recommendation M.2370. Now if you see this figure, on the x-axis we have years starting from the estimated year 2020 to 2030. If you consider any estimation graph, now on x-axis you will have the year, and on y-axis you will have the, since it is a number of mobile subscriptions, you will have the number of mobile subscription. If it is M2M subscriptions, you will have M2M subscription on the y-axis. Now depending on the estimation parameter, on y-axis you will have the estimation parameter, on x-axis you will have the years estimated from the year 2020 to 2030. Now if you see this figure, on the x-axis you will have the years, right? If you consider any figure also, on x-axis you will have the year. Now the estimated year is from 2020 to 2030. Now on y-axis you will have the number of mobile subscription in billions. In billions you will have the number of mobile subscriptions, right? Now in 2020 it is estimated that there will be 10.7 billion mobile subscription, right? In 2020 it is estimated that there will be 10.7 billion subscription. Now we are in 2022, right? Now the actual value, that means the actual value of number of mobile subscription around worldwide in the year 2020 is expected to be 10.7, but the actual value may be greater than 10.7 or somewhat less than 10.7. Now in 2021 it is estimated that the number of mobile subscription around the worldwide is 11.3 billions, right? Around the worldwide is 11.3 billion. Now in 2022 it is estimated that now the number of mobile subscriptions globally it is 11.9 billions, right? In 2022 it is estimated that there will be 11.9 billion mobile subscription around the worldwide. Now in 2023 it is estimated that there will be 12.5 billion mobile subscriptions around the worldwide. Now in 2024 it is expected that 13.2 billion mobile subscriptions will be there around the worldwide. Now in 2025 it is expected that there will be 13.8 billion mobile subscriptions around the worldwide. Now in 2022 its value is expected to be 14.4, and in 2027 it is expected to be 15.1 billion mobile subscriptions, and in 2028 it is expected to be 15.7 billion mobile subscribers, and in 2029 its value is 16.4 billion mobile subscriptions, and in 2030 its value is 17.1 billion mobile subscriptions. Now what we can conclude from this estimated graph is that as you go by year by year, the number of mobile subscription keeps on increasing because the technology gets improved, right? In every aspect you will get more as you go year one generation to the other generation, right? From 1G to 2G the data rate has been increased, and also the number of mobile subscribers also has been increased. Now from 2G to 3G again the data rate has been increased, right? And the connectivity coverage area is also improved, and again the number of mobile subscribers are also increased. Now from 3G to 4G video calling has come into existence, and the data rate has been improved, capacity has been improved, coverage area has been improved. All these factors are responsible for number of mobile subscription. As you go year by year, that means as you go from one generation to other generation, the number of parameters will get into, the number of new parameters will come into existence. Because of that new parameters which is very useful for the user, the number of mobile subscribers will get increased, right? Now what we want to conclude from this estimation is that as you go year by year, the number of mobile subscriptions will increase. Why it will increase? Because the new technology will come into existence, the user will get adapted to that new technology, right? And that's why the number of mobile subscription, the data rate will be increased. From one generation to other generation the data rate will be increased, capacity is maintained high, and the mobility is also maintained high, and also number of connecting devices per kilometer square, nothing but the connection density is also improved, right? As you go year by year, the technology gets improved in every aspect. The technology gets improved, which is responsible for the attraction of the user, because of that new technology the users get attracted to it. As a result the number of mobile subscriptions will get increased, right? Now what we can conclude is that as you go from year by year or from one generation to the other generation, the new technology will come into existence, which will get adapted by the user. Now because of that the number of mobile subscription will get increased, right? Now if you see, it is 10.7 billion under 2020 and 17.1 billion under 2030, and these values are estimated values, but the actual values will get differ with the estimated values, but nearer to it, you will get nearer to it. Now as you go from 2020 to 2030, in 2020 the 5G came into existence, and in 2030 we may expect 6G, right? Now from one generation to other generation, if you go from one generation to other generation, the number of mobile subscription will get increased around the worldwide, not only in one particular country, around the worldwide the number of mobile subscriptions will get increased if you go from one generation to the other generation, or if you go year by year, right? Now coming to next slide, we have estimation of global mobile subscriptions with different categories. Now in previous slide we have estimation of global mobile subscriptions, right? We have seen just estimated values of mobile subscribers around the worldwide, that we have seen in previous slide. Now in this slide we will see the estimation of mobile subscriptions around the worldwide with different categories. What are those different categories? One is the user using the smartphone, and another one is user using the tablet, nothing but tab and other smart devices, and another one is user using the featured phone. Now if you observe this bar graph, right, now the blue colored region, right, you have blue colored region, red colored region and green color region, maroon, somewhat maroon reddish, right. Now this blue color region is responsible for the users using the smartphone, right, users using the smartphone, and this maroonish color, right, you have maroonish color. Now this value, that color is responsible for the users using tablets, nothing but the tab and any other smart devices. And if you see this green color, now these are the users, these are the users that are using the featured phones, that means basic smartphone or basic mobile phone, right. Now if you see an x-axis, you will have the years starting from 2020 to 2030. Now all the estimation that we are seeing is from the year 2020 to 2030. If you consider any estimation, not only this estimation, the previous estimation of global mobile subscription is also from the year 2020 to 2030, and this is also is from 2020 to 2030. And later coming estimations, after this we will see some more estimation also, those estimations are also from the year 2020 to 2030, right. Now on x-axis you are representing the years 2000, starting from 2020, 21, 22, so on up to 2030. Now on y-axis, right, on y-axis, now what is the parameter here? Global mobile subscription, right, mobile subscription in billions, right. In billions we are number of mobile subscriptions with different categories. They, in previous slide we don't have any categories, just we have estimated the values of mobile subscriptions around the worldwide. Now here the estimation is of number of mobile subscription with different categories around the worldwide. Now on x-axis we are representing the year starting from 2020 to 2030. On y-axis we have the, what is the parameter here? Number of mobile subscriptions with different categories, and the value is in terms of billion, right. Now in 2020, 6.3 billion users will be using the smartphone, because the blue colored region is of smartphone, users using the smartphone, and 1.3 billion people will be using the tablet and other smart devices, and 3.2 billion people will be using the featured phone, basic smartphone or the featured phone. Now in 2022, 7 billion, if you see in earlier year, that is in 2020 it is only 6.3 billion. Now here in 2021 it is 7.0. That means the users using the smartphone will keeps on increasing, right. The users using the smartphone, as you go year by year, the users using the smartphone will keeps on increasing. If you see in 2022 it is 7.8, again greater than 7, and in it is 8.8, 9.8, 10.4, 11, 11.3, 11.6, 11.9, 12. All these values are the users using the smartphone in different years, right. If you go year by year, its value is increased, and here also its value is increased, right. Now what I want to conclude is that the users using the smartphone will keeps on increasing as you go from 2020 to 2030. Now coming to users using the tablets and other smart devices, in 2020 it is expected that 1.3 billion users will be using the tablets and other smart devices. Now here 1.5, and again this value is also increased. Here it is 1.3 billion and here it is 1.5 billion and here it is 1.8 billion. Dot should be there, but it is not represented here, but it is 1.5 billion, 1.8 billion and 2.2 billion, 2.6 billion, 3 billion, 3.4, 3.7, 4.1, 4.55, right. Now what you can conclude is that as you go from 2020 to 2030, the number of users using the tablets and other smart devices will also increase, right, will also increase. This bar graph shows that as you go from year 2020 to 2030, the number of users using the smartphones is increased and the number of users using the tablets and other smart devices are also increased. Now coming to third category, that is featured phone. Now the green color region is of featured phone. Now in 2023 that it is estimated that 3.2 billion mobile users will be using the featured phone. Now in 2021 its value is 2.8 and in 2022 its value is 2.3 billion and in 2023 its value is 1.5 billion and in 2024 its value is 0.8 and in 2025 its value is 0.4. Now what you have to conclude from this estimation is that as you go year by year 2020 to 2030, the users using the featured phone, nothing but basic smartphone, will get decreased. Now by the year 2025, right, by the year 2025 or the 2026, there will be no user using the featured phone, basic smartphone. There will be no user using the featured phone, right. Now from the 2026 we will be having only the users using the smartphone, tablets and other smart devices. We don't have any users using the featured phone, right. Now from this estimation and this is also collected from that ITUR recommendation, that is M.2370. Now from this estimation what we can conclude is that as you go year by year, that means as you go from the year 2020 to 2030, the number of mobile subscribers, nothing but the users using the smartphones, will keeps on increasing and the number of users using the tablets and other smart devices will keeps on increasing and the number of users using the featured phone from the year 2020 to 2030 will get decreased, right. Now we don't have any user using the featured phone from the 2026 to 2030, right. Now this was about the estimation of global mobile subscriptions with different categories, that is smartphone, tablets and other smart devices and featured phone, right. As you go from 2020 to 2030, the number of users using the smartphones will increase and the number of users using the tablets and other smart devices will also increase and the number of users using the featured phone will get decreased. From 2026 we won't see any user using the featured phone, right. Now this was another estimation. Now coming to the third estimation. Now this estimation is of global M2M subscriptions, nothing but machine to machine subscription, right. Now if you see this estimation, now this estimation is also from the year 2020 to 2030, right. Any estimation, all these estimation are collected from that recommendation M.2370. Now all these estimations are estimated from the year 20 to 30. Now on x-axis you will be having the year, on y-axis you will be having the number of M2M subscriptions in billions, right, number of M2M subscriptions in billions, right. Now in 2020 we have 7 billion M2M subscriptions, nothing but machine to machine subscription, and in 2021 10 billion M2M subscriptions, and in 2022 it is estimated that there will be 14 billion M2M subscriptions, and in 2023 it is estimated that there will be 19 billion M2M subscription. Now in 2024 there will be 26, it is estimated that there will be 26 billion M2M subscriptions, and 34 billion M2M subscriptions is under 2025, it is estimated in 2025, and 45 billion M2M subscriptions are estimated in 2026, and 57 billion M2M subscriptions are estimated in 2027, and 17 billion M2M subscriptions are estimated in 2028, and it is estimated that there will be 84 billion M2M subscriptions under 2029 and 97 under 2030, right. Now from this estimation, what we can conclude, as you go year by year, that is from 2020 to 2030, the number of machine to machine subscribers will also increases, right. The number of M2M subscribers will also increases, right. Now this was collected, if you see this table, now this was collected, these are the actual values, right, years 2010, 2011, 2012, 2013. Now these are the actual values, these are the estimated values, and these are the actual values. Now in 2010 we have 213 million M2M subscriptions, and in 2011 we have 324 M2M subscriptions, and all these estimations are around worldwide, right, not only one particular country, all these estimations are around worldwide. Now in 2012 we have 376 million M2M subscriptions, and in 2032 we have 422 million M2M subscriptions. All these values are from the previous years, these are the actual values. Now the estimated values will be in billions, right, will be in billions, because we will have a new technology coming into existence under 5G. 5G will support machine to machine subscriptions, machine to machine communication. Now because of that, the basic machine to machine communication has started from the 5G. Earlier we don't have any machine to machine communication in previous generations. We have machine to machine communication from 5G onwards. Now we will have advanced version in 6G and 7G, right. We have advanced version of this M2M communication under 6G, and again advanced version under 7G. This keeps on going, right. Now from this estimation, what we can conclude is that as you go year by year, the number of M2M subscribers, nothing but machine to machine subscriptions, will keeps on increasing, right. Now in the year 2020, it is estimated that there will be only 7. Now within a span of 10 years, right, within a span of 10 years, it will go till 97. That means around 12 times, around 12 to 13 times, right, 12 to 13 times greater than its previous value, right. In 2020 we have only 7. It is estimated that we will have only 7 billion M2M subscriptions or the subscribers, but in 2030 we have 97 billion, which is 13 times greater than the 2020 value, right. Now what we can conclude is that as you go year by year, the number of M2M subscriptions, nothing but machine to machine subscriptions, will keeps on increasing. The number as you go year by year, 2022, as you go from 2020 to 2030, the number of M2M subscribers will also increase. If you see these actual values also, if you see below table, we have from the year 2010 to 2013. Now the actual values will also keeps on increasing, whether it may be actual value or the estimated value, whether it may be global mobile subscriptions or the M2M subscriptions with around the worldwide, always the value keeps on increasing because of introducing new technologies into the coming generation, right. Now coming to next slide, we have estimation of mobile traffic in 2020 to 2030. Now this estimation includes machine to machine traffic also, M2M traffic also, right. We have without M2M traffic also. After this we will see that estimation of global mobile traffic without M2M traffic, and this slide is of with M2M traffic, right. Now on x-axis we have from the year 2020 to 2030. If you consider any estimation on x-axis, you will be having the year starting from 2020 to 2030. On x-axis you will be having the estimated parameter, right. Now here the estimated parameter is mobile traffic, right. Now the traffic per month is represented on y-axis and the year is represented on x-axis. Now the unit for this traffic per month is exabytes. Exabytes is nothing but 10 power 18 bytes, right? Exabytes, you have gigabytes, terabytes. Giga is nothing but 10 power 9. After giga you have terabytes, that is 10 power 12 bytes. After terabytes you have petabytes, PB. PB is nothing but petabytes and its value is 10 power 15 bytes. And after petabytes you will have exabytes, EXA bytes. Now that includes 10 power 18 bytes. Now after exabytes you will have zettabytes, ZB. ZB is nothing but zettabytes. Now its value is 10 power 21, 10 power 21 bytes, right? The you will for every increment in the bytes, from giga it is 10 power 9, and from tera it is 10 power 12, from peta it is 10 power 15, exa is 10 power 18 bytes, and after that you will have zettabytes, that is 10 power 21 bytes, right? Now here if you see this estimated graph, now in 2020, now the traffic is 62 hexabytes per month, right? The traffic is 62 hexabytes per month, and in 2021 it is 99 exabytes per month traffic, and in 2022 its value is 158, 249, 390, 607, 938, 1439. All these values are in terms of exabytes. Exabytes is nothing but 10 power 18 bytes, right? 10 power 18 bytes traffic per single month, right? Now what we can conclude from this estimated graph is that as you go year by year, as you go from the year 2020 to 2030, the traffic, whether it may be including M2M or without M2M, the traffic keeps on increasing, right? If you see, in first generation we have very less traffic, and in second generation we have somewhat more traffic than the previous generation, and from 3G we have again traffic has been increased, and in 4G again traffic has been increased, and in 5G again traffic has been increased, and in 6G again the traffic will also increase, right? As you go from one generation to the other generation, or as you go year by year, the traffic keeps on increasing very heavily. Now if you see, in 2020 its value is 62 exabytes, and in 2022 it is 158, which is more than twice, right? 62 into 62, which is nothing but 124, and here we have 158, right? More than twice traffic, if within a span of 2 years. 20 to 22 we have only 2 years. Within a span of 2 years the traffic has been increased by 2 times. Now again if you consider 2022 to 2024, here it is 158, and again it is increased by twice, right? If you go again, it keeps on increasing as you go from year by year, or as you go from one generation to the other generation. The estimated values, not only estimated value, the actual values will also increase, but the actual values will get nearer to the estimated values, right? Now from this estimated graph, what we can conclude is that as you go from 2020 to 2030, the traffic will keeps on increasing. Very heavily, right? Now if these are the estimated values, and here these are the actual values, right? Now in 2005 we have only 0.9 mobile traffic, which is petabyte per month, right? Petabyte per month. Petabyte is nothing but 10 power 15. Now again in 2006 its value is 4, and in 2007 its value is 15, increased by 3 times and nearer to 4 times within span of 1 year. Now in 2008 its value is 38. If you see, it is 15 and here it is 38, increased by twice. Now in 2009 it is 92, and in 2010 256, and in 2011 597, and in 2012. All these values, mobile traffic values, are in terms of petabytes per month, nothing but 10 power 15 bytes per month, right? These are the actual values. This table is also collected from that ITR recommendation only. These are the actual values and these are the estimated value. Whether it is actual value or the estimated value, what we can conclude is that the mobile traffic will keeps on increasing. Within a span of 1 or 2 years only, the mobile traffic is getting doubled, right? If you see here, within a span of 2 years the mobile traffic is getting doubled. Now here you can observe the mobile traffic is getting triple, right? Here it is 4 only, 4 petabyte per month, and here it is 15 petabyte per month. Now within a span of 1 or 2 years, that mobile traffic will be double, right? Now from this slide, what we can conclude is that with including M2M subscriptions or without M2M subscriptions, nothing but machine to machine traffic, if the traffic includes machine to machine or if the traffic doesn't include machine to machine, whether the traffic includes M2M or without M2M, the traffic will keeps on increasing if you go from the year 2020 to 2030 or from one generation to the other generation, right? What we want to conclude is that as you go from year by year, as you go from 2020 to 2030 or from one generation to the other generation, the mobile traffic without M2M or with M2M, nothing but with machine to machine subscriptions or without machine to machine traffic, right? With M2M traffic or without M2M traffic, the traffic around the worldwide will keeps on increasing, right? The traffic around the worldwide it keeps on increasing. The actual, if you consider this actual values also, it keeps on increasing. In 2005 we have only 0.9 petabyte per month, and in 2012 we have 885 petabyte per month, right? Now what we can conclude is that as you go from year by year, as you go from 2020 to 2030, the mobile traffic including M2M will keeps on increasing. Within a span of 2 years only it is getting doubled, right? Within span of 2 years only it is getting doubled, right? In 2020 we have 62 hexabytes traffic per month, and in 2030 it is expected that its value will be 5016 hexabytes per month. That means as you go from 20 to 30, within a span of 10 years only, the mobile traffic has been increased heavily. The mobile traffic has been increased heavily. Now coming to next slide. Now here we have estimation of mobile traffic by different service type globally, right? Now if you see this, now again, and its estimation is from the year 2020 to 2030, right? Now if you see this graph, now the green color graph will be M2M subscriptions and M2M services, and non-video is blue color, and this maroon color is of video, right? Now what we can conclude from this estimation is that the more traffic is from the videos only. Estimation of mobile traffic by different service type globally, and the different services are video, non-video and M2M subscription, because we will be having the users using the videos only, because if you consider any user will be using the video only, because video services are greater if you compare with the other services like non-video and M2M. This graph shows like this only. This estimations, right? Now these are the estimations only, but the actual values may differ, but what we are concluding is that users will be concentrating on the videos rather than non-videos and M2M services, right? Machine to machine services, right? From this estimation, what we are concluding is that users will be the concentration of the users, we will have more number of users using the videos only rather than the users using the non-video and M2M services. Now here these are the actual values from the year 2010 to 2013. Now here these values are under exabytes. EV is nothing but exabytes, and here you have terabytes. Terabytes is nothing but 10 power 12 bytes, right? Now here we have 1,11,272, and here you have 266, 387, 406, 124, 669, 249. These are the services, non-video services that are supported in the year 2010, and non-video services that are supported in the year 2011, and non-video services that are supported in the year 2012, and 6,69,249 are services that are supported, non-video services that are supported in the year 2010. And the same for the video, we have 117,943. If you compare these values, right, if you compare these values, we have 6,000, somewhat 6,000 users will be concentrating on the grade. We have this value is greater than this thing, right? That means more users, if you see this particular line, you will have a clear idea. For the non-video, we will have 1,11,272, and for video we have 1,17,000 in the year 2010. Now in 2011, here we have 266, and here we have 307, and 406, 455, 667, 669, 858, and the M2M subscriptions are lower, right? Now what we can conclude is that the users, the first services used by the user will be video services, after that non-video services, after that M2M services, right? Now this graph shows that now estimation, actual values will also predict the same, and estimated values will also predict the same. We are not predicting the exact values, we are stating that then there will be more number of users using the video services if you compare with the non-video and M2M. First, more number of users will be concentrating on the video, after that more number of users will be concentrating on the non-video, and after that M2M services, right? Now from this estimation, what we can conclude is that users will be more concentrating on the video rather than non-video and M2M services, because the first priority of any user will be to the video services, after that he will give priority to the non-video services, after that he will give priority to the M2M, machine to machine services, right? Now if you consider any user, basically you will concentrate on video only, after that non-video services, after that M2M services, right? Now from this estimation, what we can conclude is that as you go from year by year, the users using the videos will keeps on increasing. Non-video services are also increased, and M2M services are also increased, but the users will concentrate more on the videos. After video services, they will concentrate more on non-video services, and after that they will concentrate on M2M. So this is the priority of different services for the user, right? Now from this estimation, the final conclusion is that users will concentrate more on videos and more on video services rather than non-video services and M2M services. Now after video services, they will concentrate more on non-video services, and after that they will concentrate on M2M services. If you see this actual values also, the same thing is predicted over here. The users will be concentrating more on video services, after that video services users will be concentrating on non-video services, later M2M services, right? Now this was the another estimation in different services, that is video, non-video and M2M. As you go year by year, the users using the video, non-video and M2M services will keeps on increasing, but they will concentrate more on video. After video, they will concentrate more on non-video, and after that they will concentrate on M2M services. And coming to the next slide, here we have estimation of global traffic per subscription per month from 2020 to 2030. Now here M2M is not included. In previous slides we have seen traffic including M2M. Now here we are seeing the estimations without machine to machine traffic, right? Here M2M is not included. Now the same thing, on x-axis you will be representing the year starting from 2020 to 2030, and here on y-axis you will be having the traffic. Now here the estimated parameter is traffic per month, and its units are gigabytes, nothing but 10 power 9 bytes. Gigabytes, nothing but 10 power 9 bytes. Now estimated value of traffic in the year 2020 is 5.3 gigabytes per month, and in 8.1 gigabytes in 2021 and 12.1 gigabytes in 2022. and in 2023 its value is 18, 26.9 in 2024, 39.4 in 2025, 57.5 in 2026, 83.5 in 2027, and 121.3 in 28, 177 in 29, and 257.1 in 2030, right? Now if you see these values, as you go year by year, the traffic will keeps on increasing. Earlier only I have said, whether you include machine to machine or include machine to machine traffic, or you don't include machine to machine traffic, the traffic will always keeps on increasing if you go year by year, right? If you, nothing but if you go from one generation to the other generation, because for every span of 10 years we will be expecting one generation, right? One new generation. Within a span of 10 years we will be expecting one new generation, that is one new mobile standard generation. That's why we have considered only a span of 10 years in this estimation. Now from 2020 to 2030 there is a span of 10 years. Nothing but as you go from one generation to the other generation, the mobile traffic will keeps on increasing. Whether you include M2M traffic or without M2M traffic, the mobile traffic will keeps on increasing as you go from one generation to the other generation, or as you go year by year, right? Now from this slide what we can conclude is that as you go from 2020 to 2030, the mobile subscriptions will keeps on increasing. The mobile traffic, nothing but the mobile traffic will keeps on increase. Here the estimated parameter is mobile traffic, right? Now as you go from 2020 to 2030, the mobile traffic will keeps on increasing, whether you include M2M traffic or without M2M traffic, right? It follows the same scenario. As you go from 2020 to 2030, the mobile traffic will keeps on increasing. Now this is without MTM. Now with MTM also, as you go from year 2020 to 2030, the mobile traffic will keeps on increasing, right? Including M2M traffic or without including M2M traffic, this statement is same. Now the statement is, as you go from one generation to the other generation, or as you go from year by year, the mobile traffic will keeps on increasing. This point you have to make a note of it. Now coming to the next slide, right? Now if you see this figure, now this is the traffic daily profiles of five major mobile applications. Now what are those applications? Streaming, computing, gaming, communicating, and storage. Now these five, we are now in this slide we will see the status of these five major mobile application, and this is in the North American region, which is estimated in the year 2020, right? Now the five major, NAR indicates North American region. Now this is the daily traffic, right? Since it is a daily traffic, now here on x-axis we have considered starting from the 12 am to 1 pm. On y-axis we have represented the estimated parameter, that is daily traffic, percentage in terms of percentage, that is percentage of daily traffic, right? Now this slide will give a clarity of five major mobile application. One is streaming, computing, gaming, communicating, and storage, right? Now coming to this storage, this line is of storage, right? Now this line is of storage. You can see this color is same. Now this line is of storage. Now from 12 am to 7 am, from 12 am to around 7 am, this value is I, because at that particular time we won't use phone, because it is under the we will keep the phone aside. That's why this value is high during this time, and again it's low for the remaining time, right? Now coming to the gaming application, gaming is represented in green, right? At this particular time we won't use any phone around 6 am, right? 12 am to 6 am we won't use any phone, but we have chances of using the phone for the purpose of gaming around 6 am to 1 pm. Again its value is gone like this, right? And the same thing for your computing, communication, and streaming, right? Now this particular no need to remember, but for your idea I am giving. From the early morning, nothing but 10 a.m. to 6 a.m. Users won't use mobiles. Because of that particular reason, now the streaming is also low. Streaming is also low. If you this particular thing, the streaming is also low because the persons won't use mobile at this particular time. Streaming is low, and for the remaining time it may vary. Now computing is also low because the persons won't use users won't use mobile at this time, and for the remaining thing it will vary. And the gaming also, here it is low. Except storage, the 4 other mobile applications will be under low state because the persons won't be using the mobile at that particular time, and for the remaining time we have the chance of that users may use the mobile phone, but that's why there is variations in this particular, right? Now streaming, computing, gaming and communicating, these four applications are absent from 12 am to 6 am because user won't be in a position to use the mobile phone at that particular time. There are users who are using that particular, but to the maximum extent of time, because all users will be under sleep mode. To the maximum extent of time, we are giving this statement to the maximum extent of users. Now the streaming, computing, gaming, communicating, all these 4 applications will be under low state around 12 am to 6 am because maximum users will be under the sleep mode, right? The storage is high because we have storage purpose is high at this particular, and for the remaining it is low. Now starting from 6 am to 1 pm, all these values, streaming values, computing value, gaming value, communicating value will vary according to the user, right? According to the user, right? Now from this slide, what we can conclude is that from 12 am to 6 am or around 7 am, all the users will be under sleep mode. Now the 4 applications, that is computing, gaming, streaming and communicating, can't be done by the user. That's why these values are under low state from 12 am to around 7 am, and for the remaining 7 am to 1 pm, these values will vary according to the user's usage. Now coming to the storage, this value will be high from the 12 am to 6 am because it is under storage condition, and for the remaining maximum users will use the phone from 7 am to 1 pm. That's why it is low, right? 4 major applications, that is streaming, computing, gaming, communication, will be under low state from 12 am to 6 am, and after that it will vary according to the user. Now storage, this will be high under from 12 am to 6 am, and for the remaining it is low. This is the major idea. For your idea I am saying no need to remember this, right? Now coming to the next slide, we have capabilities that are predicted for the these are the predicted capabilities for voice and data application. We have different applications like voice and data applications. After that we will see multimedia applications. After that we will see Internet of Things, and after that we will see low latency condition. We have different applications, right? And all the capabilities are just predicted using this figure, right? Using this figure we are just predicting the capabilities in different applications, right? Now coming to the first predicted capabilities and in voice and data application, right? Now this figure shows the predicted capabilities in voice and data application. Now we have different parameters. Now the parameters will be same, right? Its value will different for different application. Parameters will be same, but its value is different for different application. Now here we have different parameters. What we have? Connection density, right? Now connection density is nothing but number of connected devices per kilometer square, right? And next we have data rate. You know what is meant by data rate, right? And next we have capacity density, nothing but the capacity. And next we have spectrum efficiency, nothing but the bandwidth efficiency. And next you know the mobility, and next you know the battery life, coverage area, and here we have latency. These are the different parameters these are the different parameters. These are the different parameters that we are predicting in the application of voice and data. These are the different parameters that we are predicting in the application of voice and data, right? Now connection density is nothing but number of connected devices per kilometer square. Now in this voice and data application, now the connection density will be in the range of 10.3 to 10.5. its value is 10. This red line indicates the values of different parameters, right? Values of different parameters. Now this red line indicates the values of different parameters. Now connection density value will be in the range of 10.3 to 10.5 in voice and data application. Now these are just predicted values. These are just the predicted values, but its value may differ with the actual values. Now the data rate is expected to be greater than 10.7 and less than 10.9, right? And again you have high capacity density and the bandwidth efficiency is very high, and the mobility is greater than 40 km per hour and less than 400 km per hour. And we have next we have battery life, right? Next we have battery life. Now this battery life is expected to be around 1 day, because for any voice and data application, nothing but we will use maximum we will use under the mobile, but the battery life is expected to be is expected to be 1 day, right? And next we have coverage reliability, right? Now the coverage area, it should provide high coverage, that's why very high coverage it should support the very high coverage. And the latency, coming to the latency, it is supporting greater than 100 millisecond, right? Now these are the different predicted values in voice and data application, right? These are the different predicted values in voice and data application. Connection density is nothing but number of connected devices per kilometer square. Now its value is predicted in the range of 10.3 to 10.5, and the data rate is predicted value in the range of 10.7 to 10.9, and the capacity density will be high and the bandwidth efficiency is very high, and we have mobility somewhat less than 400 km per hour, and it should support battery should give it should support a battery life of 1 day, and coverage should be very high, and latency should be greater than predicted value of latency is 100 milli greater than 100 millisecond, right? All these are the predicted values of different parameters like connection density, data rate, capacity density, spectrum efficiency, mobility, terminal battery life, coverage reliability, latency. These are the different parameters with predicted values in the applications of voice and data. Now this is also collected from that ITUR recommendation only, that whatever the figures that are represented in this particular lecture, all those figures are collected from the ITUR standard, that is 2370, right? Now this is about the predicted values of different parameters in voice and data application. Now coming to the next slide, we have predicted capabilities predicted in the study of multimedia application, right? Previous is of voice and data applications, now this is of multimedia application, right? Now multimedia application, the connection density, nothing but number of connected devices per kilometer square. The range is same here, 10 power 3 to 10 power 5, and the data rate is predicted to be same again here, 10 power 7 to 10 power 9, and it should provide extremely high capacity density, right? It should provide extremely high capacity density. Now here you have to see where the red mark touches this particular parameter, and extremely high spectrum efficiency, and here the mobility is less, mobility is just only 4 km per hour, and the battery life is same, it should support up to 1 day, and very high coverage reliability, and the latency is decreased here, right? Latency is expected to be 100 millisecond. Now these are the predicted values of different parameters like connection density, user experience, data rate, capacity density, spectrum efficiency, mobility, terminal battery life, coverage reliability, latency. All these parameters predicted values in multimedia application, right? All these values are predicted in emerging multimedia application. For connection density, it is 10 power 3 to 10 power 5 kilometer per kilometer square, and the data rate is in the range of 10 power 7 to 10 power 9, and it should support extremely high capacity density, and it should give extremely high spectrum efficiency, and the mobility is less, just 4 km per hour, and it should support up to 1 day, and coverage reliability should be very high, and the latency is somewhat decreased. If you compare with the previous voice and data application, there you have a latency greater than 100 millisecond, but here you have a less latency, that is 100 millisecond, right? Now these are the different values, different predicted capabilities in emerging multimedia application, right? Now coming to the next, now multimedia application is completed. Now coming to the next, capabilities predicted in the nothing in envisaged is nothing but the predicted in the study for emerging Internet of Things, nothing but IoT sensor and actuator application, right? Now the purpose of IoT is to connect more number of devices in a single platform. That's why the connection density is very high here. If you see this graph, you will have a clear idea. Internet of Things will connect more number of devices, right? Internet of Things, that's why connection density, it will predicted value is 10% highest connection density. Now the we don't require highest data rate, that's why the data rate is very low, that is less than 10 power 3, and the capacity density is also low, and bandwidth we don't require that much high, that much extremely high bandwidth. That's why just a normal high bandwidth is just sufficient, and mobility less than 4 km per hour. And coming to the battery life, right, we are designing a device, right? Here we are designing a device where you can connect that device contains more number of components. It should support for more number of days. That's why the battery, that's why the terminal battery life is expected to be more than 1 year, because the Internet of Things is nothing but we are making a device where you can connect more number of components into it. We are making a particular device, its span should be for more number of days. That's why the terminal battery life is greater than 1 year, and it should give a coverage reliability extremely high, because you can make a devices with you can use, that means for user purpose you can design a device, right? For user purpose you can design a device such that it should support extremely high coverage area. Now here the latency is somewhat greater than 100 milliseconds, right? Latency is not, low latency is not required here, but 100 milliseconds, somewhat greater than 100 milliseconds, less than 200 milliseconds is sufficient for Internet of Things and actuator application, right? Now these are the different predicted values in the emerging Internet of Things and actuator application. The Internet of Things, nothing but connecting more number of devices, that's why the connection density is very high. We don't require high data rate, that's why a normal data rate is sufficient here, and normal capacity density, low capacity density is enough here, and we don't require very high efficiency, bandwidth efficiency. A normal high bandwidth efficiency is sufficient here, and the mobility is also less because it is less than 4 km per hour. Now the components, the device should support for more number of days. Whatever the device that we have made using this more number of components, right, that device should work for more number of days, right? Whatever the device that we are designing, that device should work for more number of days. That's why the terminal battery life is greater than 1 year, and the coverage reliability, it should provide extremely high coverage, and the latency, it should greater than 100 millisecond but less than 200 millisecond is the latency that is provided by the, that is predicted by the Internet of Things and actuator application, right? Now this is about another thing. Now coming to the next slide. Now this is about low latency application, mission critical and low latency application. Capabilities predicted in the study for emerging mission critical and low latency application. The name itself, we can predict the value low latency. Now the latency is low, right? Now here the low latency is 1 millisecond, right? Now the connection density, we don't require more number of devices for this low latency application. That's why it will be its predicted value is 10 power 3, and the data rate is also somewhat greater than 10 power 3, and capacity density is low, and spectrum efficiency is just normal high efficiency, and mobility is 4 km per hour, somewhat less than 4 km per hour. And this device will support up to 1 day, that is terminal battery life will support up to 1 day, and the coverage reliability is extremely high. If you see this coverage reliability, that is extremely high, right? Now if you see this slide, now this slide includes the capabilities predicted in the study of critical and low latency. Critical condition, for critical condition, right, if a user is under danger condition, there it should give the exact location of that particular, that's why coverage should be extremely high. That was the one application where you can use this particular critical application, that's why coverage area is high, right? Now low latency indicates 1 milliseconds. We don't require high number of devices, more number of devices, that's why less. Data rate is also less, and capacity density is also less. Spectrum efficiency is just a normal high, and mobility is just less than 4 km per hour, and the battery life supported should be is up to 1 day. And under critical condition we expect more coverage. We expect more coverage under critical condition. If the user is under critical condition, we expect more coverage, so that we can help that particular user very instantly, right? Now the latency is 1 millisecond. Now this is about the predicted values in emerging critical and low latency application. And next we have beyond 2020, right? All this we have seen: multimedia application, low latency, and we have seen internet of things, right? We have seen internet of things, and we have seen voice and data application. We have seen different applications with different predicted values, right? Now this figure will give you a clear idea of in the study for future IMT for 2020 and beyond 2020, for different application capabilities predicted in this study for future IMT for 2020 and beyond 2020. Altogether, all application together for the year 2020 and beyond 2020, right? Now if you see this figure, we have connection density, we have connection. Now this dotted line indicates this may require for the other some application, may be needed for some application. This require for may be need. Now this dotted line indicates, now this is a requirement for other application. This is a requirement for we may require for other application, right? Now if you see this, we expect low latency for IMT 2020 and beyond IMT 2020. That's why low latency is of 1 millisecond, right? Now the connection density will be in the range of 10 power 5 to 10 power 7. This value is sufficient, but for some other application we may require higher connection density. That's why this dotted line indicates, this dotted line is for other few application. Now the data rate will be in the range of 10 power 7 to 10 power 9. All the applications we have seen in the previous slides, for the connection density will in the range of 10 power 5 to 10 power 7. The same is represented here, and the data rate is also 10 powers in between 10 power 7 to 10 power 9. This is sufficient, but for some application we may require higher data rate. That's why the dotted line is extended over here. And the capacity density, it should provide high capacity, and spectrum efficiency, very high spectrum efficiency. And the mobility, for some application we require high mobility. That's why dotted line is extended over here. But normally for few applications we require less mobility, that is up to 4 km per hour. And the terminal battery life is up to 1 day, and very high coverage. We don't require extremely high unless and until user is under critical condition, right? And here we have very high coverage reliability is sufficient for any application, and the latency is millisecond, right? Now these are the predicted values for future IMT, nothing but 5G and beyond 5G. These are the predicted values for 5G and beyond 5G, right? We expect for 5G we expect low latency. Now that is 1 millisecond started from here, and 10 power 5 to 10 power 7, the range between 10 power 5 to 10 power 7 is for connection density. That means 10 power 5 to 10 power 7 devices are connected per kilometer square. The range in between, either it may be greater than 10 power 5 or less than 10 power 7. The range of connection density is in between 10 power 5 to 10 power 7. But we require more number of devices for few applications. That's why dotted line is extended over here. Now data rate we require in between 10 power 7 to 10 power 9 for 5G and beyond 5G. For few applications we require higher data rate, that is dotted line extended over here. And the capacity, it should provide extremely high and very high bandwidth efficiency or the spectrum efficiency. And for few applications we require high mobility, that's why dotted line extended over here. And for few applications we require low mobility, that is less than 4 km per hour. And the battery life is up to 1 day, and the reliability is of coverage reliability is of very high, and we extremely high coverage reliability is provided for the users under critical condition only. Now these are the predicted values. These are the predicted values for future IMT, nothing but the 5th generation and beyond 5th generation, right? These are the predicted values of connection density, data rate, capacity density, spectrum efficiency, mobility, battery life, latency, coverage reliability. These are the 8 parameters. These are the 8 parameters, predicted parameters for 5G and beyond 5G. The dotted line indicates for few applications we may require high connection density, high data rate, high mobility. Those are represented using dotted line, right? Now these are the predicted capabilities. Now coming to the next slide. Now in this slide we will see what are the technologies that are required to increase data rate, right? What are the technologies that are required to increase data rate, we will see in this slide. Now the first technology that is required to enhance data rate is nothing but the spectrum, right? As you increase the spectrum, utilization of large blocks of spectrum in higher frequency band. This is the one of the technique through which you can increase the data rate. Now another technique is carrier aggregation, right? Carrier aggregation is also one technique where you can assign multiple frequency blocks to the same user. Carrier aggregation is one more technique that is used in the wireless communication to increase the data per user, where you are assigning the multiple frequency blocks to the same user. These are the two techniques under the spectrum through which you can increase the data rate, right? Now the coming next technology under physical layer, right? Under physical layer, using different modulation technique, coding and MIMO and massive MIMO, these are responsible for increasing the data rate. Spatial processing that includes MIMO and massive MIMO, using different modulation technique and coding, these are responsible for increasing the data rate. And the next one more technique to increase the higher data rate is network densification, right? Network densification. Now it refers to the adding more cell sites, right? Adding more cell sites within a specific area to increase the network capacity. In order to increase the network capacity within a particular area, you are adding the more cell sites. Now those cell sites may include, either it may be RAN, nothing but radio access networks, either it may be macro sites or small cell installation. If you are adding the more number of cell sites within a particular area, the network you can increase the network capacity, right? Now these are the 3 different technologies through which you can increase the data rate, right? First one is utilization of large blocks of spectrum, in higher frequency bands through which you can increase the data rate. And next one is using the technique carrier aggregation. Carrier aggregation is nothing but where you are assigning multiple frequency blocks to the same user, right? Multiple frequency blocks to the same user, that is the technique of carrier aggregation. For a particular user, for the particular same user you are assigning multiple frequency blocks through which you can increase the data rate under spectrum. And coming to the physical layer, by using different modulation technique, by using different codings, and by using spatial processing, nothing but the MIMO and massive MIMO, using these techniques you can increase the data rate under physical layer. And under spectrum you can increase the data rate by utilization of large blocks of spectrum. And another one is carrier aggregation, nothing but assigning same frequency blocks, nothing but the multiple frequency blocks, assigning multiple frequency blocks to the same user. And another technique in order to increase the higher data rate under network is within a specific area, you are adding more number of cell sites in order to improve the network capacity, These are the three different technologies through which you can increase the higher data rate. One is the spectrum, using the large blocks of spectrums in higher frequency band, and another one is carrier aggregation technique. And under physical layer you are using different modulation techniques and coding techniques and MIMO and massive MIMO in order to increase the higher data rate. And under network, in order to improve the network capacity within a specific area, you are adding more number of cell sites. These are the three different technologies through which you can enhance the higher data rate, right? Now coming to this slide, if you see this slide, overview of timeline for IMT development and deployment, right? Now in 1985 to 2000, now the third generation IMT 2000, it took around 15 years, right? For normally any generation will take 10 years only, right? Normally in 2000 third generation came into existence, and in 1980 first generation came into existence, and in 1990 second generation came into existence, right? Second generation came into existence in 1980, right? In addition to 2G only, we are adding some features. Now that results in 3G. From 1985 to 2000, total 15 years is allotted for the development of third generation after the deployment of third generation. And in next we have from 2002 2003, vision of fourth generation has been started, and 2003 to 2012, total 9 years has been taken for the development of advanced, right? And after that deployment of IMT advanced. And next we have vision 2012 to 2015, 3 years has been taken for the vision for fifth generation communication system, and for the development it has took only 5 years, and after that deployment, right? What I want to say is that total 15 years has been taken for the third generation, development of third generation from 1985 to 2000, and after that deployment of third generation has been started. Now from 2000 to 2003, vision of fourth generation, nothing but IMT advanced. Vision of fourth generation from 2003 to 2003, that is IMT advanced, and for development it took 9 years, and later it is deployment of IMT advanced. And for 2012 to 2015, again 3 years for vision, right? Nothing but set of goals, processing, all this, right? And for the development 5 years has been taken for the fifth generation, after that deployment. This is the total overview of IMT development and deployment. IMT is nothing but third generation, IMT advanced is nothing but fourth generation, IMT 2020 is nothing but fifth generation, and for sixth generation you may expect IMT 2030, right? 15 years for 3G, 9 years for 9 years plus 9 years for development only, 15 years for development for 3G, 9 years for development for 4G, nothing but IMT advanced, and 5 years for development of 5G, right? Now all these figures that I have collected from ITER recommended standard, and in next lectures we will see the different usage scenarios of a fifth generation system, right? Thank you.